Hello everyone, today my team, me, Hao Jun and Ling Xing will go through with you the principles of biostatistics, which is quite important especially for those who are going to do their major project soon. This is the table of contents we'll be going through for today. Firstly, the basic statistic concepts, followed by graphs, and lastly statistical tests. The basic concepts that will be covered are the population and sample, then the measures of central tendency, measures of variation dispersion, shape of a distribution, confidence interval and the research flow. Population versus sample. A population is a collection of all items of interest to our study. Population can be hard to define and observe, time-consuming, and can be quite costly. This is why people use sample instead. Since sample is only a portion of the population, it is easier to define and observe, saves more time, and obviously would be less costly. Let me give you an example. Let's say there's a study that wants to find out the jobs prospects of students studying at X Polytechnic. What do you think is the population and sample? You might think if that's the case, it is quite easy, right? Just walk into the Polytechnic and interview everyone in school. But this is actually not your population. The population includes all students, which includes, but not limited to, full-time students, so students on campus or at home, exchange students, part-time students, etc. While the sample can just be a portion or subset of the population. So it can be, for example, the students on campus. So from this simple example, you can see that it is quite hard to define and include the whole population. So to save time and effort, we use sample instead of population. Measures of central tendency. Don't be intimidated by the chim words like central tendency. It basically is a summary statistics that represents the middle point, which is also the typical value of a dataset, which indicates where most values in a distribution falls. They are also referred to as the central location of a distribution. There are three main measures of central tendency, namely mean, median, and mode. Mean is your simple average, the sum of all your values divided by the number of observations. The mean is generally used unless outliers exist. The population mean is called mu and the sample mean is called x bar. The median is the middle number in an ordered data set. It simply means that you rank your data according to smallest to largest, then you take the middle number. That's your median. While mode is the most straightforward. It is the most frequent value in your dataset. Let's move on to an exercise to help you understand better. Here listed are the weights of 5 fishes: 100 gram, 300 gram, 500 gram, 100 gram, and 2000 gram. To calculate the mean, you just sum up all the values and divide by the number of observations. In this case, it's 5, and you will get the mean to be 600 grams. To find the median and mode, you first have to rank your data according to the smallest value to the largest value. Then you'll get the ordered data set as follows. So if you find the median, the middle number would be 300, and mode, the most frequent number, would be 100. But obviously when you do your major project, more often than not you will have a much larger data set, maybe a sample size of 250. Of course you're not gonna manually type into the calculator one by one to calculate the mean, median or mode. You can simply use Excel to help you out. The Excel function for median is average, median is median, and mode is mode. Measures of variation dispersion is a summary statistic that represents the amount of dispersion in a dataset. How spread out are the values? While previously we went through measures of central tendency describes the typical value. Measures of variability, on the other hand, define how far away your data points tend to fall from the center. A low dispersion indicates that data points tend to be clustered tightly around the center, while high dispersion signifies that they tend to fall further away. The two common measures of dispersion is variance and standard deviation. Variance is defined as the average of squared differences from the mean. What it means is that firstly you find the mean, then you take your data value minus the mean, square it, then the sum of all your data value divided by the number of observations is your variance. The formula is quite complicated, so it will make more sense in the example later. The population variance is the sigma square, while sample variance is S square. Standard deviation is simply the square root of variance. This is the same example previously given. If you recall, the mean is 600, so to find the variance, you take 100 minus 600 square plus 100 minus 600 square plus 300 minus 600 square plus you go on and on. Then you divide the sum by 5 if it's a population. But if it's a sample, you divide by 5 minus 1, which is 4. You'll get the variance to be 640,000. So to find the standard deviation, you just simply square root that value and you'll get 800. Again, you just have to know what variance is. You don't have to manually calculate it one by one for your MP. So if you use Excel, the Excel function is var.s for variance of sample and stdev.s for sample standard deviation. Shape of a distribution describes how data are distributed. The two commonly used measures are skewness and kurtosis. Skewness measures the extent to which data values are not symmetrical, while kurtosis measures the thickness of the curve of distribution. As you can see from the illustration, the left skewed and right skewed are both not symmetrical in shape. The skewness statistic for left skewed, symmetric, and right skewed is less than 0, equals to 0, and more than 0 respectively. This illustration shows the thickness of the curve of distribution. Leptokurtic means it has a sharper peak than bell shape, with kurtosis stat more than 0. Mesokurtic is your bell shape, with kurtosis stat equals to 0. Platykurtic means it has a flatter peak than bell shape, with kurtosis stat less than 0. So what's the significance of knowing the shape of the distribution curve? Here lies the answer. In a normally distributed data, it will be symmetrical and bell-shaped. In other words, if your data is left skewed or right skewed, it is not normally distributed. Also, if your data is leptokurtic or platykurtic, your data is also not normally distributed. If you use Excel, the Excel function for skewness is skew and kurt for kurtosis. Confidence interval. Usually we wish to estimate population parameters using the observed sample data. So for example, we use sample mean to estimate the population mean. A confidence interval provides an estimated range of values which is likely to include an unknown population parameter. Using the previous example, imagine weighing 5% of the fishes in Singapore and then saying that the average weight of the fish is 600 grams. You may be close, but chances are that the true value isn't really 600, but somewhere around it. When you think about it, it is much safer to say that the average weight of the fish in Singapore is somewhere between a range of values, for example 400 gram to 800 gram. In this way, you have created a confidence interval around your point estimate of 600 gram. A confidence interval is a much more accurate representation of reality. It quantifies the level of confidence that the parameter lies in the interval. We commonly use 95% confidence interval. So what does 95% confidence interval mean? 95% confidence interval is a range of values that you can be 95% certain contains the true mean of the entire population. A side note, you can never be 100% confident unless you go through the entire population. Also, the more samples you use, it will provide a more representative result and a better confidence at 95% interval. You will reject your null hypothesis if your p-value is less than 5%. This will be talked more in depth later. The research flow. So let's say on your first day of internship, your supervisor walks up to you and says, "Hey intern, there's a fish called jade perch and it's a potential aquaculture species for local fish farms. I want you to go and find out what are the effects of increasing salinity on the growth performance of jade perch." The very first step you should do is to ask questions. Second step is to do background research. Third step is to construct your hypothesis. Fourth step, test with an experiment. And lastly, the fifth step is to analyze and report your results. The first step, ask question. Any research must begin with a clearly stated question, and it is the most crucial step to design your experiment. If we refer back to the previous case study about the jade perch, the question to ask would be, what are the effects of increasing salinity on the growth performance of jade perch? Moving on to the second step, background research. You should find out more on the topic of study. For example, finding out more about the fish, jade perch, its common name, habitat, diet, and the recommended optimal water parameters like ammonia, nitrite, nitrate. Find out more about previous study done on salinity and what are the different measures for growth performance indicators like average weight, average length, specific growth rate, and feed conversion ratio, etc. The third step is to construct your hypothesis. Previously, you have the question statement and you should state your null hypothesis and alternative hypothesis using that. Hypothesis testing uses falsification to conclusively disprove a question, and you should always start with the simplest null hypothesis with the least assumptions. So, for example, in the case study, your null hypothesis would be in increasing salinity, the growth performance of jade perch would not be affected, and your alternative hypothesis would be in increasing salinity, the growth performance of jade perch would be affected. The fourth step is to test with an experiment. Before you start, you must be very clear on what is your control and treatment. The control helps you to test whether a treatment has an effect on an organism. Everything must be the same. The sampling method, the effort, the food have to be the same except for the treatment. So referring back to the case study, the control would have fresh water, its salinity would be 0 ppt, while the treatment would have increasing salinity like 10 ppt, 20 ppt, 25 ppt, and 30 ppt. You would only change the salinity while everything is kept constant. Another important thing to note is the sample size. You should choose a realistic sample size that is appropriate to the size, density, and dispersion of the organisms you are sampling. For example, 100 prawns individual versus 4 lion individuals. You can easily get 100 prawns from a supplier and they are easy to handle, but you probably would have a hard time looking for 1 lion in 1000 hectare reserve. So be realistic and don't try to get 100 lions. PS. The magic number 4 is a minimum sample unit size sufficient to determine significance difference in your data. You may also want to do as many replicates as possible to get a more representative data, but it will take more time and money to achieve, which is very true in the real life. You probably won't get to decide on a lot of things. For example, you might want to get a sample size of 300 jade perch, but your supervisor might just say, oh, they already ordered 100 jade perch juveniles. So you need to get the best trade-off between precision and cost. The fifth step, analyze and report your results. You should decide on the appropriate statistical test during the design phase that links back to your research question. The test can either be parametric or non-parametric depending on your data. If your data is normally distributed, you use a parametric test, but if it's not normally distributed, you will use a non-parametric test. More details will be given on how to perform this test later. So this concludes the basic statistic concepts that will be covered by me.